Hey guys, so today we've got notes on our last type of transformation that we're going to cover, and that is a dilation, which if you think about it, if you've ever went to the eye doctor and had your eyes dilated, your pupils get really large, much larger than normal, or if a light is shined in your eyes, they talk about how your eyes dilate. So a dilation is where you enlarge a shape, or you might actually shrink it. So it can either get smaller or larger, just like when our eyes dilate. So most of these types of transformations are self-explanatory in their name. Reflections reflect, dilations dilate, rotations rotate. Translations slide. So that one's not as easy, but remember I told you guys to remember that the translation has an SL in it, which should help you remember slide. So this is your table of contents updated for today. The two pages that we're going to do today, dilation and dilation examples, should be page 7 and 8 in your notebook. So we make sure that you have your table of contents updated like mine. Pause here if you need it. Pause at any time if you are going slower or faster than I am and you need to go back. Pause, fast forward, any of those things you're able to do that on your video. So I'm going to flip to page 8 now. And I have glued in the dilation notes. So these are attached to today's Google Classroom assignment. They are blank. If you are able to print them out and glue them in, that is wonderful. It'll make your life a lot easier. If you're not, that's totally fine. You can just write this into your notebook. Again, you can pause this, write all this down, and then press play when you're ready. You can do this at your own pace. So dilations, the definition of a dilation is a transformation in which a figure is enlarged or reduced. So all of these types of movements that we've talked about are transformations or ways that you can change something on the coordinate plane. So a dilation is just making something bigger or smaller. Dilations create similar figures. So it's not going to be the exact same that just got turned or got slid across the coordinate plane. It's similar but not exact. The scale factor indicates how much the figure will enlarge or reduce. And so scale factor is going to be noted as K. So if your K or your scale factor is greater than 1, it's going to be an enlargement. If it is less than 1, it will be a reduction. And what you're going to do with that scale factor is you're going to multiply your coordinates by that number, whatever it wants you to scale it to. So if they give you points and they want you to dilate it up 3, you're going to take those numbers and multiply them all by 3 and get a much larger picture. If they want you to multiply it by 10, you'll get a much larger picture as well. So a dilation, as you can see with our smiley faces, we've had these smiley face examples every time. This one, it's similar, but the new image is smaller. Or if this was the original and this is the dilated image, it's larger. So we're going to do 2 examples together, and the last example I'm going to leave blank, and I want you to fill it out so I can check that when you come into class. So our first example. Here, it tells us that triangle ABC has vertices at these points, and your vertices are just your corners here, the outside points of our triangle. So if these are the ordered pairs, those are the coordinates ABC, we have a scale factor of 3. Now, since this is a positive 3, I'm going to be multiplying by a positive 3. So your pre-image points, A is negative 5, 5, B is negative 5, 10, and C is 10, 0. Our dilation is 3. So our K value is 3. So what I'm going to do is every number gets multiplied by 3, and I'll get a new image. So I have just put times 3 beside every number. Negative 5 times 3 is negative 15. 5 times 3 is 15. Negative 5 times 3 again right here is negative 15. 10 times 3 is 30. And then down here, 10 times 3 is 30. 0 times 3 is 0. So we have these previous points, and now our new image is going to be 3 times bigger than our first image. So if we were to plot these points, we would see a triangle. If we were to plot this one, it would be 3 times as large as the previous image. So this is the pre-image before it was transformed, and this is the image after it's been transformed with a dilation of 3. So this is really simple. It's basically multiplication. As long as you're putting the numbers in the right spot, you know where they go, and you know how to graph them, then you should be good to go. Let's do one more together and graph it, and then I'm going to leave the last example for you to do on your own. Flipping over, this is the second page that was attached to today's Google Classroom assignment. This has example 2 and 3 on it. So I'm going to use orange this time. So it tells us to graph the triangle ABC, and it tells us those coordinates of A, B, and C. So I'm going to write those down right here. A is -2, 0. B is 2, 4, and C is 4, -4. So if our dilation is a factor of 1/2, that means I'm multiplying everything by half, or 0.5. Basically, I'm taking every number and cutting it in half. So 2 times 1/2, or -1/2. I'm sorry, -2 times 1/2. The 1/2 is not negative. 1/2 times -2 is going to give me just -1, and 0 times 1/2 is 0. Anything times 0 is 0. Let me write this right here for you, just like I did previously. -2 times 1/2, 0 times 1/2. 2 times 1/2, 4 times 1/2. And 4 times 1/2, -4 times 1/2. So that way you can see I'm taking that scale factor and multiplying both coordinates by that number. So if we have 2 times 1/2, you're basically taking half of that number. So what is half of 2? It's 1. And half of 4 is 2. Half of 4 is 2. Half of -4 is -2. So those are going to be our new numbers. So now we're going to plot them. So I'm going to do pink for the pre-image, and then I'll do orange again for what we just did. So -2, 0 is A. 2, 4 is B. And 4, -4 is C. So we've got a large triangle right here. So now when we plot our image, our points are -1, 0, 1, 2, 2, -2. Those are not straight, I apologize. I've got this spiral up under my hand. So -1, 0 was A prime, this was B prime, and this is C prime. So as you can see, it is smaller, which makes sense because we multiplied everything by 1/2. So our previous numbers were larger than our final numbers, making our new triangle much smaller. Remember on the first page we talked about your scale factor. If it is less than 1, your dilation is going to be a reduction, and 1/2 is less than 1. So our new shape should be smaller than our original. So our pre-image that had not been transformed in any way was the large pink triangle, and then our new image that was dilated at a scale of 1/2 is much smaller. So I'm going to leave example 3 blank. I want you guys to do this and complete it on your own. That is all you have to do today. Copy down your notes and fill this in. Upload that. Let me check on that and see that. And then when you come in class, we will practice these things together. These are your 3 points that go here beside your letters. Look at the scale factor. So it's very similar to what we did up here, but this is -1/2. So watch those signs. 2 negatives multiplied together is a positive. Don't think that means negative. So negative times negative is a positive. Okay? And then anything times 0 is 0. But this is not a point. This is just letting you know it's centered at 0. It's going around the origin. So you guys do this last one on your own. And then I will check that and we will do some more practice with this later on. All right, thanks guys.